Hello. I'd like to thank the organisers for inviting me to speak and to you for coming to listen. So I'm going to be talking about some work we've been doing introducing programming in year one of the chemistry syllabus at York. And this is partly in response to demand from students and partly following up on some work that's already been done in biology. So, my background, I've been teaching programming at York for nearly 2 decades to chemists, and the first version of the course ran as a year 4 option module and taught them Python. And this was a very traditional course where we started from the building blocks and built up. So, constants, variables, expressions, assignments, and so on. And after about 4 lectures, the students would get to the point where they could start to build a useful program that would do some data analysis, something they couldn't do before. Now, the outcomes of this course were not great. About 20% of students would get to the point where they could use programming in their projects or labs. And that subset was biased male. And I explained this at the time, following the conventional wisdom that programming was an aptitude, it required a specific mindset, and that there were some people who could naturally do it, but most couldn't. Now, I hope I am going to show you that I was wrong about pretty much everything there. So then we went on to a new version of the course in R, and that was very useful because R is taught in a different way typically. And then this year we introduced a new version in Python where we teach the material to the whole cohort in year 1 with the aim that everyone should be a programmer and should use the skills in their labs. So the plan was that this would be delivered to all year 1 chemists with 6 hours of contact time. COVID changed that and probably helped us out. We delivered it electronically. We used 12 short videos totaling about 90 minutes, and then it was supported by online exercises, quizzes and Q&A forums. Some of those may change once we can do face-to-face teaching. So here's how we teach them. We start with a practical and useful program that the students can run and use straight away, and then we take it apart. So here we have a 4-line program. It reads in a library, reads in a data file, it prints a table of statistics, and it plots the data. So it's immediately useful. And then we take it apart to find out how it works. So we have to learn about one variable that we've used, the assignment statement, which gives it a value, and 4 function calls following 3 different patterns. And that takes about 15 minutes. There's a certain amount of complexity to unpack, but it's 15 minutes to get to a point where they have a useful program that they understand. So then we go and build on this. So the next thing we get them to do is read some files and plot them, taking files from our wet lab server. So these are files that have been generated by students in previous years, and the current students will be generating similar files. And different instruments produce data in more or less complex formats. So it's a bit of a puzzle figuring out how to plot all of these. Then we go on to some more complex data analysis. Here we want to analyze reaction kinetics. So we read in some reaction data, we take a logarithm to linearize it, and then we do a least squares fit to the data, including printing a table of summary statistics, some of which the students can understand. And finally, we plot it. So this is running at the same time as the kinetics course, so it links in very closely to what they're learning in another context, just as we previously linked into labs. Finally, we want to introduce loops and conditional statements, so we have them loop over a whole load of data files and analyze reaction kinetics. So these are reactions of different orders, so they have to try different linearizations and fits and decide which one is the correct order and calculate the reaction rate appropriately. So the course is structured as 12 short videos. This gives you a little bit of the context and an idea of what we're covering. And I want to draw particular attention to lecture number 3, which is labelled History, Psychology and Sociology of Programming. In fact, it's mainly dealing with structural bias and particularly gender biases. So I'll take you very briefly through the contents of that lecture and give you an idea of why it was important to incorporate it at this point in the course. So I talk a little bit about the history and the fact that before a computer was a machine, computer was a job, and it was typically a job that was done by a woman. So it was only natural that the first electronic computers would also be programmed by women. And similarly, we have the hidden figures here, and Grace Hopper, who developed the first modern computer language. I take them through my mother's programming career and the shift in gender balance she saw during the course of that career, to the point where today we see very small numbers of top contributors who are women on the main programming sites. I talk a little bit about influences, things which cause this to happen, and the pink collar phenomenon. And then this is the central slide of the talk, which focuses on Stack Overflow. Whenever you ask a question on the internet, on Google, about computing, the answer is probably on Stack Overflow. And men and women experience the environment at Stack Overflow very differently. In a free format answer, men used very different words to women in describing the nature of the site. And we can understand this in terms of there being distinct gendered communication styles, which can be used to make even anonymous online forums hostile to different groups, exclusionary to some groups. So this is something very concrete that the students can go and see happening now, and then I've given them hooks into the theory to understand how structural bias is working in this situation. So then we talk a little bit about the implications, stereotype threat, and how it creates performance anxiety. How we've learned a little bit from R, which achieves better inclusion. And finally, how the students can use this knowledge to improve their own experience and find resources and collaborative sites which support them both intellectually and psychologically. So did it work? Unfortunately, I have more work to do before I can answer that question for you. So where does the gender disparity come from? There is some work on gendered learning styles which suggests that different teaching approaches may make a difference. But I would suggest that actually the causes are more basic. Traditional teaching methods, tools and online communities are structured to make programming hard, to make it an elite activity, so that only those whose society is primed to believe that they can and should be programmers can overcome the energy barrier to get to the point where they can do something useful. So the solution for us has been to draw attention to the barriers and teach in a way which weakens them by making the coding immediately useful right from the very beginning. Now, for me, how I developed this course and how I've come to the ideas here is highly linked to my autism. So I experience social interactions as extremely complex, and I have to develop rules in my head for how to navigate them for situations which everyone else seems to understand instinctively. And this leads to a great deal of social anxiety for me. Now, interestingly, when I started listening to transgender and non-binary students, I began to realise that a lot of the complexity which drives my anxiety is associated with complexities around gender roles. So for me, that suggested that I needed to learn more about gender performance, and I started living as gender fluid, and that began to make more sense of it, but it also, the experience of learning to perform a new gender role and living in that role gave me the questions I needed to ask of the scholarly literature to understand the role of gender in its role in computing. So that influenced the teaching methods. Now, does everyone need to do this? One feature of autism is that it leads to a poor theory of mind. I'm bad at getting into someone else's head. So maybe someone who is not autistic could have done all of this without also being gender non-conforming. Having said that, the people I see who are teaching computing in ways which break down gender barriers are primarily women. So it could be that it's important to experience exclusion in order to teach in ways that subvert it. So whether that's the case, that's a question I'll leave with you. Okay, so that's what I wanted to say. I'd like to thank lots of people who've helped make this course possible and open the floor for questions. Thank you.